go. Hi folks, Tormach 440, Fusion 360. Let's try machining a DIY injection mold. Welcome to another Wednesday widget. I'm super excited for this. So Peyton over at X39 Brick Customs sent this over to us, and he said, do you think this is something we could make on a 440? I think he was trying to decide if that would be a good machine for him. And I don't really know, I mean, I'm inclined to say yes, but I've never made an injection mold like this, but it seems so cool. And Peyton was a good dude. He actually sent us the little Lego guys. He made these up for us and sent them over to our open house, and we bought some. So if you want to support our channel, these are available for sale on our Saunders Machine Works website. So let's do this. We've got a chunk of aluminum. We are going to do a very quick walkthrough on the Fusion 360 cam. We'll do a deep dive later, and then we're going to go machine this thing on the 440. So the mold itself is obviously two sides. Today we're going to focus just on this left side. So I'm going to hop back into cam, and I broke the cam up into a few different sections. The first is called roughing it. So that's where we're going to handle facing it off, the adaptive around it, because our stock is a little bit bigger than the OD of the mold. Contouring, this is basic stuff, drilling, and then we are going to rough out and pencil out the, I don't know mold terms, flow slots where the injection mold material gets pushed in. So it'll actually get pushed in under pressure through here, and then the two little slots, one is right here and one is right here, are what allow the material to flow into the mold. But that's the quick and dirty stuff. Then we're going to focus on the left side. And again, I'm being pretty conservative, I think. We're going to start with the 3/32 end mill, which is huge and funny compared to the ones we're about to use. A 1/16 flat, 1/16 ball, because that ball end mill is going to be able to get into a lot of areas that the 1/16 flat can't get. And then the idea here is basically to get rid of the material with as strong a tool as possible until we get down to these last two, which are 1/32. Again, I'm going to do a flat, then a ball, and then finally we're going to do a scallop. And the scallop is going to be what cuts all of the final geometry. So all of these above here have some amount of stock to leave. So the idea is, again, that you're using this last tool to cut everything in one sort of pass. Hopefully it looks good. Hopefully it meets their expectations. Hopefully it makes a good part. Shear hog time. I should have run the shear hog down 10 or 20 thou lower. That way this finish tool here was only cutting on the side and not on the bottom. You can see it's leaving a little trough here. Not a huge deal, but it's better to do it right, and that would have been an easy fix. So you guys do that. Pencil Toolpath 3/16 ball end mill, where the hot plastic will flow to get into the mold. Let's throw a quick chamfer on this as well. So we're also going to share the CAD and CAM model for this on our Patreon website. So if you support our channel on Patreon, it's, you know, most people give about $2 a month. You can download this. Now we can't share the exact interior model because obviously that's you know, the property and sort of proprietary to the customer here. But what we did is we talked to them, and we're just going to change some of the internal geometry so that it's no longer the exact model, but it's something that we can share. So if you want to see some of the details of the CAM toolpath, the CAM settings, just play around with this, cut your own, and you're interested in supporting the videos that we make, again, as little as a few bucks a month, you can support us on Patreon. So I'm not happy with the surface finish on the penciled slot there. And I have to think that that's important because the smoother that is, the less friction there'll be, and the better that the injection molded material will flow, which is really important because it's got to push down here, out the sides, and into the mold die. So, you know, this is the time to put our A game on. So I'm going to run the same operation again with that same tool with just a negative 1,000 stock to lead axially. So it's just basically going to run over the same exact tool path. And let's just see if that cleans it up. If it doesn't, I got another idea. Okay, that actually did help. I'm concerned that the camera makes it look worse than it is. And I'll admit, I think it could be better, but it's not chowdered up or chattered like I thought it might be. Customer says, you know, hey, you know what, that needs to be even better next time. We'll, what I would have done was used a smaller tool instead of the full diameter and done a step over pass, basically like how we're going to make the mold. That way you don't have this issue where you've got 100% tool engagement and you're effectively both climb and conventional milling at the same time. So, you know, you're putting more pressure on the tool, more deflection, more difficult chip evacuation, and so forth. Although, hey, look at that. I love that. All right, now comes the real part. Here's our setup for this job. This makes me so happy. It's like such a stress reliever because we've got our bins. I got my tool in it. Just tore, it's quick and dirty, you know, tore off a piece of paper with the tool number on it. And then I got the extra tools right here because, you know, these are really small tools. I'm not used to working with, you know, 1/32 end mills. You can barely see the damn thing. That's 30 thousandths. I think we're probably gonna break some tools. So I've got the tools to measure my tool runout, my Heimer, my tool set gauge, and just nice and easy. Link for these in the video description. The Schaller is awesome, American made. These bins are cheap, and they've been great. They're a big part of our shop organization project. All right, here we go. 3/32 end mill, 2 flute. This is a hogging operation. So we're going to focus again on just this one left side of the mold. Let's see how it goes. This is a pretty quick tool pass. The smaller tools just have a slower feed rate, so they're going to take a while. I think the cycle time is about 1 hour 20 for the left side, which is pretty long. I could be longer. On the flip side, I suspect I'm being really conservative with the number of operations, you know, doing these progressively finer and adaptive tool paths. Maybe not, but I suspect I might be being conservative. But I'd rather be conservative and get this done well. I just find it demoralizing if you try to kind of go for it and it doesn't work. You don't know, did it not work? Why didn't it work? So again, I'd rather take my time, get a good tool path, and then start working, find out areas where I can dial this in. That was just the 1/16 flat, and boy, I gotta say I'm pretty happy with how that looks. This camera won't focus too close, but the surface finish quality is pretty good. And we've got a bunch more tools to go here. Next up is the 1/16 ball. So I'm not checking runout, by the way, on the 1/16 tools because honestly, they're still pretty rugged and I'm not too worried about them breaking. And the surface finish doesn't matter as much because it's not creating any of the final geometry. That's not to say that you shouldn't check the runout like we did in our video last week on a tool this small, but I mean, if you guys know my channel, I mean, we gotta make this stuff. If I don't need to do it, I'm not going to do it. So we will check it on the 1/32. After the 1/16 ball end mill, so far really happy with the quality though. Tool runout. So this is the 1/32 flat end mill. When I put it in and turned the dial, it was rotating or running out about 7/10. So I went to the high spot, just like we did in the video last week, and punched it with the screwdriver and the hammer, and it's now at 4/10. Is it? Yeah, 4/10, which I'm told is within the acceptable range. You know, less is better, but 4/10. Here's the real question. Let's run this op, and then let's measure this when we're done and see if it bumped back. My God, it's tiny. I haven't broken the tool yet. That's good. And that's adapting. So that's the beauty of it. This is why I love Fusion 360. I really do. And so these adaptive tool paths are awesome. I think we talked about this in when we made that oil mold for the motorcycle, because it means I'm not going to break this tool, or much less likely to break this tool, because I'm taking constant chip load cuts. So it's not going to dive into a corner, dive into a bunch of material, increase the tool engagement angle, and it's just awesome. We can hog out, quote unquote, hog out with these progressive adaptives, and then finally use a scallop toolpath. It's a beautiful 3D toolpath. I'm really excited to see what it does. Okay, good, we didn't break a tool. So far I've only broken the biggest tool, the 1/8 inch tool. I'm really curious to see what this is gonna read though. Really curious. The Nogas with the finger adjustment in the base are so much freaking better. This is Amazon, not even that expensive. I love it. Okay, here's the big moment. So I told you we were at, well, let me adjust it back to 0. It's almost like there's some slop in the indicator. Clearly it moved. That's getting to 5. So we bumped it to 4. It was at 7/10 originally, so it stayed closer to the position where I bumped it, which is good. I threw in the 1/32 ball. It was about 7/10 as well, and I bumped it down to, right now it's at 2/10. So this is going to be an even better test. Let's see what this one's like when it's done. We're partway through the 1/32nd fall. I'm super excited to see how this works. This is so cool, I think. Okay, here's the scallop. We're done. We didn't break the tool. Let's check that runout. Are you guys, is it just me, or is this also super exciting to you guys? Like this idea of just dialing in tenths on tools and getting these really, really good tool paths, and the idea of just using a $5,000 base price machine or 10 loaded to do this kind of work. Hey, well, it's jumpy. Why does it do that? We're getting some error. Let me find another spot, maybe. Wow, talk about an idiot moment. The chips. Good grief, John. It's acting differently. Why is it doing those little hoppy hops right there? Am I touching? Oh, I'm starting to, okay. One last freaking time here. Can someone explain this to me? It's acting like there's no run out, and then all of a sudden it'll do that little jerk. What was that? What was that? Is that just a chip? It might just be a chip. It looks like it held though. Here she is. First of all, you can see the mirror reflection. The Superfly remains an awesome tool, but I'm really happy. You know, I'm not a mold maker. I've never done this before. I don't know if I've ever used a 1/32nd end mill before, and I just love it. The fact that we get these tool paths out of Fusion, and then it's so affordable, and this machine is so relatively low end or low cost, and look what it's making. Look at this. Now, what I think of its looks doesn't matter. It's going to be a question of what the customer can do in terms of making their mold out of it. So we're going to find out. We're going to machine the other half. We'll send it off to them, and the proof is in the pudding. But for my first time, I'm pretty darn happy. It just looks cool. I'm sure we're leaving time on the table. Like I mentioned, we can do a better job, but this is freaking awesome. So I'll ask Peyton if maybe he can do any filming when he throws it, or just show what happens in his shop with how he runs and makes this. But awesome, folks. So look, thank you. I hope you guys enjoyed this, something different for us. Again, there's a deep dive, link in the video description to the deep dive into some of the CAM. And we really appreciate the folks that produce or that support the channel on Patreon. $1 a month, $2 a month, $5 a month really helps us justify the time to put out these videos. And there's a link there to where you can download this CAD and CAM Fusion file, again, just with a generalized bore so that we're not giving away the secret recipe here for his exact design. As always, folks, I appreciate the thumbs up and comments below. Take care. See you next Wednesday. Check it out. 2 sides are done now. Throw some pins in. I have no idea if this is how he does it, by the way, but I assume that there's some sort of a guide pin or dowel pin like this. And let's see here. That would be the other half. And together she gets clamped. Boom.